concept for today is going to be IVR, which is called as Inter VLAN Routing. And how this inter VLAN routing is going to work, the name itself suggests that whenever you have multiple, I would say, networks in your VLANs, then you can use this inter VLAN routing so that they can communicate together. So we saw a topology yesterday that whenever you have, I would say, a switch that is connected to multiple devices. Okay, let's say this is your VLAN 10, and then you can have your VLAN 20 and your VLAN 30. Then, even though they all might be into same network like 192.168.1.0/24, they still will not be able to communicate from here to here and from here to here. The communication won't be possible. Why so? Because they all, the hosts are into different VLANs. However, hosts that are connected in same VLAN can communicate together. That's what we saw, right? But today we are going to see another example. Now this IVR has two, I would say, methods. The inter-VLAN routing can be implemented by two methods. One method is called as SVI, and the other method is called as ROAS. Okay, so we will explore this SVI first, and then we will explore the ROAS. So what is this? What does this SVI means? SVI stands for Switched Virtual Interface. And in order to implement both the methods of inter-VLAN routing, you need a layer 3 device. Okay, so in order to implement this switched virtual interface, we will be using a layer 3 switch. Okay, that will be also called as a multi-layer switch, MLS. And what are we going to do is we are going to have this multi-layer switch. Okay, and this multi-layer switch will have multiple PCs connected with it. This is going to be A and that's going to B. Okay, then you will have C and D, and then you will also have E and F. This A and B are going to part of network 192.168.1.0, and they are also going to be part of VLAN number 10. Make sense? Then we will also have second network that will be participating in 192.168.2.0/24, and it will participate into VLAN number 20. And then for the third link, I would say we will have 192.168.3.0/24, and we will have VLAN 30. So we will have our topology like this, where we have a multi-layer switch and we have some PCs connected. The first network is going to have 192.168.1.0, let's say. The second has 192.168.2.0, and the third has 192.168.3.0. The interfaces that are going to be there of the switch is going to be, let's say, gigabit 0/1, 0/2, 0/3, 0/4, 0/5, and 0/6. All right, these can be in the interfaces. So our very first task in order to implement this IVR or inter VLAN routing can be that we go on this particular switch, okay, and we create VLANs, VLAN 10, 20, and 30, and then make these ports as member of this VLAN. Okay, after you do this particular thing, then you will also assign IP addresses of different subnets to these PCs. So PC A and PCB will have an address of 1.0, the C and D will have 2.0, and E and F will have 3.0. This is how you can build up your network as. Make sense? Then what's gonna happen is we are going to create this SVI, which is called as switched virtual interface. And what is this? These are the virtual interfaces that are created on multi-layer switch. Okay, and on those interfaces, you can specify the IPs. And these interfaces, the SVIs are then binded with the VLANs. So I would say that our three VLANs, we have three VLANs, right? And in this three VLANs, VLAN 10 would have an SVI that would be interface VLAN 10. We will create this SVI and then we will assign an IP address that will be 192.168.1.1 with the subnet mask of 24. And this IP address will act as gateway for all the PCs. Correct? Then for VLAN, I would say 20, we will create interface VLAN 20, and then I will assign an IP address to that will be 2.1/24, and this will again be the gateway for other PCs. And then for VLAN 30, we will create interface VLAN 30 and 192.168.3.1/24, and that's gonna be the gateway. Do you understand that? So that is exactly how it is going to be. VLAN 10, VLAN 20, VLAN 30. So you're going to create three SVIs, and then the communication will be there, because whenever you enable the routing abilities on this particular multi-layer switch, then it would be the switch will be able to forward traffic in different networks. So inter-VLAN routing, in order to give you a quick, I would say recap, inter-VLAN routing is nothing but implementing routing on a layer 3 device between different VLANs. Whenever you implement inter-VLAN routing, then you are basically able to communicate between networks of different VLANs. That's why we do inter-VLAN routing. And you can do it by using a layer 3 device, okay, either by using a router or by using a layer 3 switch. If you just have a layer 3 switch, then you can use a method called SVI. IVR using SVI, which is switched virtual interface. And if you have a router, then you can use routing on a stick method. Okay, these two are the methods that we can use. You can configure DHCP, but if you want to configure DHCP on SVI, you need to set up a DHCP server separately. Okay, I'll also show you how you can do that in Packet Tracer. Don't worry about that. So this is how we're going to do it. And the first thing that how you would configure it is you can basically go to the PCs, assign them IP addresses of different IPs, and set different, I would say, VLAN information or gateway information on that. Then you create different VLANs on your multi-layer switch, and then assign or make those ports as member of of the VLANs, and then you create the SVIs, okay, and enable the enable, I would say, routing. This is what the process is going to be. Okay, so let's go ahead and let's do the lab for this, and I'll show you how you can implement this. So we're just going to have a multi-layer switch over here, and that multi-layer switch, now look at the lab, okay, and follow the process and let me know when you do that. So I will select a switch here, and then I will select a multi-layer switch. You can see the first device, that is 3560, and the second device is 3650. These two are two multi-layer switches we have. We will be using the first one itself, the 3561. So I will drag this device, and then I will go to the PC section, and I will connect multiple PCs with it. So I will take around 6 PCs, 1, 2, 3, 4, and 5, 6. And then what I'll do, I'll just connect them like this. Makes sense to you? These are the 6 PCs that we have. The network that we're going to have for this is 192.168.1.0/24, along with VLAN 10, that's going to be sales VLAN. Okay, for the second one, we're going to have 192.168.2.0/24, and the VLAN is going to be 20 with the name of marketing. Okay, and the third one that we're going to have is 192.168.3.0/24 VLAN 30 with the name of HR. The same VLANs that we have been creating. Okay, now what I'm gonna do, I'm gonna go to the PCs and configure IP address. On very first PC, I'll configure 1.2 along with a gateway of 1.1. However, the gateway is not configured yet, but yeah, I can go ahead and configure that my gateway IP over there. So 1.2 is going to be there. Then you're gonna have 1.3 on the second PC and gateway still as 1.1. Good. Then I'll go ahead and go to the third PC and configure 2.2 and 2.1 as the gateway. And on the fourth PC, the address would be 2.3 and 2.1. And on the third network, or I would say on the fifth PC, I will have 3.2 and 3.1. That's what the IP is going to be. And on the last PC, I would have 3.3 along with 3.1 as the gateway. Understand? So I would say that all of these PCs are in same network as of now. And if I send traffic from here to here, or if I send traffic from here to here, these guys are able to communicate together. If I keep them here to here, then they are not able to communicate because the networks are different. Makes sense? All these three networks are different. All right, so these are the I would say networks that we have. Then we will go on this particular switch and create our VLANs. That's going to be the step two. So I will write down the steps. Step one is assign IPs with gateway to PCs. Step two is create and name VLANs. Step three is basically assign members or assign ports to VLANs. Step 4 is going to be create SVIs on L3 switch, and step 5 is going to be enable routing. This is what the steps are going to be. So we did assign the IPs, then I will go to the CLI of this particular device and I will say no over here and go to enable conft. I will make this particular I will assign a host name of MLS over here, multi-layer switch, and then we will create a VLAN 10, name it as sales, take an exit. I would say VLAN 20, name it as marketing, take an exit, and name it create a VLAN 30, name it as HR, and take an exit. This is how you can do that, correct? And you can see this VLAN information by using do show VLAN brief in conf mode. And you can see that by using do show VLAN brief, we have VLAN 10, 20, and 30. Now we are going to assign the interfaces and make them members of these VLANs. So as you have 1 and 2 for VLAN 10, 3 and 4 for VLAN 20, and 5 and 6 for VLAN 30. So I will go ahead, select our range of interface. That's going to be interface range FA0/1 hyphen 2. Okay, and I'm going to say switch port access VLAN 10. Then I'll take an exit, select other, I would say range, interface range FA0/2 and 3, and say switch port access VLAN 20, and then interface range FA0 slash, oh, I selected a wrong range probably. Yeah, I'll go ahead, interface range FA0/1 hyphen 2, and I'm gonna make it as switch port access VLAN 10. Then I'm gonna select interface range FA0/3 and 4 and say switch port access VLAN 20, and then interface range FA0/5 and 6 and switch port access VLAN, I would say 30, and take an exit there. And I can see my VLANs are created. There you go. 1, 2, 3, 4, 5, 6, correct? Any questions still here? Perfect. Then what we will do, we will just create the SVI step number 4. And how do you create this SVI? You basically use a command in order to create an SVI. And for the first SVI, our switch virtual interface is going to be interface VLAN 10. Okay, we are going to use this command in order to create this SVI. Currently, you can see that there is no VLAN 10 as SVI by running do show IP interface brief command. Okay, when you run this command, you would see that these are the list of interface. It starts from 0/1, and you can run it down, and you can see that there is just one SVI by default, which is again administratively down. So it's not on, and that is dedicated for VLAN number 1, which is a default VLAN. We are going to create 3 different SVIs over here. Okay, and we're going to bind them according to VLAN information that we have. So the first SVI is going to be interface VLAN 10. And you can see that the state of that particular SVI is up now, but you need to perform a no shutdown command here. And then you can assign an IP address to it. That IP address is going to be the gateway of our first network, which is going to be 192.168.1.1, and the mask is going to be 0. Do you understand that? Interface VLAN 10, then no shutdown, and then IP address. That's the command that you need to use. Then you can take an exit and say next SVI interface VLAN 20, no shutdown, and say IP address, the next gateway, that's 2.1. Correct? And then you can take an exit and say interface VLAN 30 and say no shutdown and IP address 192.168.3.1 along with the subnet mask and take an exit. Do you understand this? We selected first interface VLAN 10, then said no shutdown and IP address. Then we did the same thing for 20, and then we did the same thing for 30. You can see that you would see 3 SVIs, VLAN 10, VLAN 20, and VLAN 30, and each SVI is up and up having the IP address that is configured. Cool. And now, if we just try to send this particular, I would say, communication, the first 2 PCs are able to communicate like this. You can see that 1 and 2 successful, then 3 and 4 successful, and 5 and 6 successful, because they both are in same network and in same, I would say, IP, same VLAN as well. But if I try to send traffic from here to here, you can see that it will be failed. Correct? Why so? Because routing is not enabled over here. If I go on this multi-layer switch, and if we see do show IP route command, you see this particular device doesn't identify any of the networks that it's working with. So in order to enable this routing, the command that you use is going to be IP space routing. Makes sense? And you're gonna hit enter, and then you can again check the IP routing command by running to show IP route. And you see now our switch recognizes these 3 networks, right? So it recognizes 1.0 is directly connected to VLAN 10. Then it recognizes 2.0 is connected to VLAN 20, and 3.0 is connected to VLAN 30. See that? And when I try to send traffic from these PCs now, that first PC wants to talk with third, the first packet will be failed, the second will be successful. Then over here, from here to here, successful. And from here to here, successful. Do you understand that? That's exactly how SVI works. Yeah, the command is just IP space routing. Makes sense? Go ahead, do this particular lab, okay, and let me know when you're done. You can follow these steps that I have highlighted over here. So I'm giving you another lab to do and see if you can do it. What you need to do is you need to take these PCs over here and the all the other thing as well. Two over here and these PCs down over here. And then you need to take another switch and connect another set of PCs with it. And then connect these PCs together. Do you understand that? And then what you need to do is you will be having different networks here. So the network that you have gonna have over here is going to be 192.168.4.0, okay, slash 24, along with VLAN 40. Cool. Then next you're gonna have the network that would be 192.168.5.0 slash 24, and this can be your VLAN for 50. And then you can have other network which is 192.168 6.0 slash 24, and this would be VLAN 60. Makes sense? So you're gonna create the same network over here, and then we will connect these two together. You get that? So what I want is these PCs should be able to communicate with the others across the network, okay, in different VLAN. So see if you are able to do this. Okay, use your own thing. I'm not going to help you at the beginning. Use your own brain, okay, based on the knowledge that you have, and let me know your inputs. Okay, I'll give you 15 to 20 minutes to implement this. If you fail, so try to look around and imagine how it's gonna do. Okay, if it's trunking, if it's not trunking, that's your part to think. Let me know if you are able to do this. You need to create VLAN 40, 50, 60, and then create SVIs for different VLANs for these networks. And then each PC should be able to communicate with each other. That's the purpose of this particular lab. All right, let's check then how to connect second topology with first. So I will go ahead and configure my second as soon as possible. I'll go on my first PC and configure the IP as 4.2. Just see this as a verification thing. 4.2, and then I will paste 4.1 here. I will close it, go to second PC and configure IP address as 4.3 along with the gateway as 4.1. And then I will close this as well. Third PC 5.2 and 5.1. Close this as well. Go to other, configure 5.3 and 5.1. Close this as well. Go to the last one, 6.2 and 6.1. Desktop 7.2, 7.1, and close it. Correct? These are going to be the IP configurations for us. Then we will go ahead and configure other things. So we will go on the second switch and I will just rename it. Sorry. Yeah, second switch. I will rename it as host name MLS2. Okay, multi-layer switch 2. And then I will create VLANs. That is going to be, last computer is wrong. Okay, sorry. It is going to be 6.2 and 6.1. 6.3, sorry, and 6.1. Yeah, so go ahead and create VLANs. That's going to be VLAN 40. Okay, I'll name it as sales 2. And then I will create another VLAN, VLAN 50. Name marketing 2. And say VLAN 60, name HR2. Good. And then I would say again, connect addresses or make the members. So I will say interface range FA0/1 and 2, switch port access VLAN 10, sorry, VLAN 40, and then interface range FA0/3 and 4, switch port access VLAN 50, and interface range 5 and 6 as switch port access VLAN 60. Do you understand that? That's how we basically create VLAN. Do show a VLAN brief. You can delete a VLAN by using no VLAN 60 command or no VLAN 50 or 40, whatever you want. Okay, just use a no before that. Then, as we are done creating the VLAN, I probably would say then we have to create SVIs. And you can create SVI by saying interface VLAN 40 and then say no shutdown and say IP address 192.168.4.1 along with the subnet mask. Correct? Then I would say interface VLAN 50 and say no shutdown and say specify IP address that can be 192.168.5.1 255.255.255.0 and then interface VLAN 60 and say no shutdown IP address 192.168 6.1 along with the subnet mask. That's how you gotta do. Then if we verify the table by running do show IP route, then you can check that the route is empty, but if I say do show IP interface brief, then you can check at the very last of the space table, you would see that there are these three new SVIs, 40, 50, and 60 that are created. Make sense to you? So that's what you gotta see there. Okay, when you have these two this configuration and your second topology will be ready over here. So if I try to send traffic from here to here successful. So not only enter, I would say the same VLAN communication would be done. The different VLAN communication for second topology will also work over here. First packet is gonna fail, second is also failed. Why is that? Oh, okay, we didn't enable routing. That's why it's failed. So in order to enable routing, we will use IP routing and then you can take an exit and show IP route and there you go. And then these packets should go successful. There you go, successful. Makes sense? Then I again try to send the same thing over here. First failed, second successful. Are we good here? Perfect. Now, in order to make these species communicate with the others, the trunking will not help you because multi-layer switch do forward the traffic based on IP as well. Okay, so if you just make these as trunk ports, then you what you will do, you will basically try to create the same VLANs over here as well, so that these VLANs have these this switch have the understanding of other VLANs, and this switch also have the understanding of the VLANs on first switch as well. But this is not going to help you because some or the other way we are creating a layer 3 network as well. So, in order to make this traffic go from here to here, you need to implement routing as well. And how you do that? You need to create a new network and connect these two, I would say, interfaces over a layer 3 link. And you got to create a network that says 192.168.7.0/24. And you will convert this layer 2 interfaces into layer 3 interfaces and assign IP addresses on them. And how do you do that? Because if I go on my FA0/7 as of now, let's say enable conft interface FA0/7, and if I say IP address 192.168.7.1, 255.255.255.0, it will say invalid input detected. Make sense to you? So what do you need to do? You need to turn this interface as a layer 3 interface. And how do you do that? You go into the interface by using interface fa0/7 command, and then you use no switch port command. And this particular command will make this port as a layer 3 port. So I will use enter over here, and then once you hit the enter, you can see that the port just restarted again. And then I'll be able to use a command called IP address. And as I hit the enter, you see that now it took the IP address. And when I go and hover my cursor on this router, you can see that FA0/7 now has an IP address that says 7.1. Do you understand that? Yeah. And then you basically go to the other thing and then say conft interface FA0/7 and say no switch port and then configure an IP address, and that IP address will be 192.168.7.2 space 255.255.255.0. Okay, and you can see that the ping from this PC to this PC will also reach. The first packet failed, the second should success. Make sense? And then what you will need to do now after doing this, in order to make these packets reach out over here, you need to implement routing by using either RIP, EIGRP, or OSPF. Do you understand that? Because when I check the routing table of my multi-layer switch, my switch just knows about 1, 2, 3, and 7. It doesn't know about 4, 5, and 6. Correct? So you need to implement routing on these switches. You see that? So what I will do, I'll just go over here and I would say router rip version 2 and say network 192.168.1.0, and I would advertise my 2.0, and I would advertise my 3.0 and 7.0, like that. And then I will go on the other switch, and what are my directly connected networks? I would say router rep version 2 network 192.168.4.0 and 5.0 and 6.0 and 7.0. There you go. And then as you take exit from that, do check your routing table again, and you will have all the routes in your switch. Make sense? And then if we try to send traffic from first PC to this PC over here, successful. And every PC will now be able to communicate with each other. Do you understand that? That is how it works. So kind of a tricky lab. Go ahead, do this configuration and let me know when you're done. I'll give you 5 minutes. Switch port mode trunk is not working because the I would say negotiation is different there. Okay, in order to make it work, you need to use a command called switch port trunk encapsulation. Now, switch port mode dynamic desirable. Okay. Now, this was about SVI. Now, compared to the same region and same, I would say, requirements, when you don't have a multi-layer switch, but you have a router, okay, and a layer 2 switch, then you implement something called routing on a stick. And what happens in that scenario is uh, you can have, I would say, same set of requirements. So what I'll do, I'll just remove the switches from here, and I will also remove these PCs that we don't really require. Okay, and we're going to have the same requirement that the number of PCs are same, but we will connect these PCs to layer 2 switch. So I take a layer 2 switch that is 2960 and connect these PCs with the same thing. Okay, and we will complete our layer 2 configuration by, I would say, creating VLANs on this switch, okay, and making these ports as member of those VLANs. So I would go on our layer 2 switch and create VLANs again. Enable conf t interface enable conf t and then VLAN 10 name sales, VLAN 20 name marketing, and VLAN 30 name HR. Okay, then after that, I will just go ahead and make interfaces as members of this VLANs. So interface, I would say range FA0 slash 1 and 2, and say switch port access VLAN 10, and then interface VLAN 3 and 4, and switch port access VLAN 20, and 5 and 6, switch port access VLAN 30. This is how you make them member of those VLANs, correct? I can take an exit from there and I can check it by do show VLAN brief. And you can see that the output of this do show VLAN brief is 10, 20, 30 have their ports. And these ports will not be able to communicate together now, right? They will be able to do intercommunication like PC1 to PC2, but they won't be able to do PC1 to PC3 because they are in different networks and different VLAN. So how do you set it? You basically connect a router with it. So we will basically take a router and connect that router with the switch. There you go. Now FA0 slash 0 is the interface that is connected off this particular. I would just zoom that out and I will enlarge the topology like this so that you understand. Makes sense? So FA0 slash 0 is the port that router is using and FA0 slash 7 is the port that switch is using. And as of now, our FA0 slash 7 is turned down and it is in VLAN number 1. Okay, then what do? We basically have an interface that is FA0 slash 7, FA0 slash 0. And FA0 slash 0 is our physical interface. And when we implement routing on a stick, that stands for ROAS routing on a stick, we create sub interfaces, meaning that we are going to flow the packets or traffic of three different networks, that is 1.0, 2.0, and 3.0, okay, via this single link. So we will need the help of sub interfaces over here. And these sub interfaces will be the part of this main interface. Do you remember that we created SVIs, but we cannot create SVI on our switch anymore. If I go and say interface VLAN 10, okay, and then when we basically do it, then we won't be able to make it a part of our VLAN. So if I just go ahead on this, Your switch after creating SVIs will not be able to do routing over here. So you will be able to make your traffic reach out over here, but your traffic will get failed because your SVIs will not have the ability to forward the traffic based on the routing table, because the IP routing command doesn't work over here, invalid input detected. So even though you can create this SVI, the routing kind of lacks on layer 2. That's why it doesn't enable you to do so. So you need the help of, I would say, router. And you create sub interfaces over here, and these sub interfaces will be FA0/0.10. The second interface, and we will assign an IP address of 192.168.1.1/24 to FA0/0.10, and then we will create another interface that is FA0/0.20. Okay, and we will assign 192.168.2.1/24 and FA0/0.30. Okay, and we will assign it an IP of 192.168.3.1/24. Do you see that? So now this number can be anything, but the best design practices says that you use a number for which the VLAN is being binded with. So if you have a VLAN 10 and you want to bind this first interface with VLAN 10, use number 10 over here. However, this doesn't really mean that this interface is working for VLAN 10. That's not how it works. Okay, there is a different command to bind this interface with VLAN 10, and we will use that. So how do you basically do it? And you don't need any physical IP address on your physical interface or any IP address on your physical interface. Your physical interface just needs to be turned on so that it can work, and your logical interfaces or sub interfaces are going to have the IP address. So you go to the router, and then you basically create your sub interfaces by turning on the physical interface, no enable conft interface FA0/0, then say no shutdown. Make sense? And then after that, you use basically a command in order to create sub interface that can be interface FA0/0.10. Okay, you use this command, and now if I don't need to give a no shutdown command, because when I create this interface, you can see that in the log you can see that FA0/0 is up, and meanwhile FA0/0.10 as well is up. Okay, so if I go on this interface and say IP address 192.168.1.1 space 255.255.255.0, it will not be configured. It says that you need to configuring IP routing on a LAN sub interface is only allowed if that sub interface is already configured as part of these protocols. So you need to encapsulate this newly created interface with some VLAN. Okay, and how do you do that? You use a command called encapsulate or encapsulation dot 1q10. Make sense? And this is where we are binding this interface with VLAN 10. Do you understand that? And then we will be able to use a command called IP address. So first, you create the interface by using a command called FA0/0.10, and then you encapsulate it with VLAN 10 by using a command called encapsulation.1q10, and then you configure the IP address on that interface. You see that? So, and then when I hover my cursor over here, you can see that the IP address that is configured is 192.168.1.1. And then such just like that, we will create other two interfaces as well. So we'll say interface FA0/0.20. Okay, then we say encapsulation dot 1q20 for VLAN 20, and then we can say IP address 192.168.2.1 along with the subnet mask, and then take an exit, and that's done for the second interface. Then I'll go and create interface FA0/0.30, and say encapsulation dot 1q 30 and say IP address 192.168.3.1 255.255.255.0. Do you get that? That's exactly how you do it. I don't think 3.1 is assigned. 3.1, 2.1, and 1.1 are working as gateway addresses to the PCs. You can see that the IPs are as gateways. Okay, and now your traffic will basically go directly to the gateway, make it reach over here, and your router will have a routing table. Do show IP route. See that 1.0, 2.0, 3.0, just like switches. Good. But there is still one problem that whenever I try to send traffic from here to here, it says it's gonna fail. And why is that? Because the traffic is going to this switch, sorry, the router, but the switch is not able to forward this traffic through this FA0/7 because our FA0/7 is still a member of that VLAN number 1 and it cannot flow traffic from VLAN 10, 20, or 30. So that's why we make it a trunk port by saying switch port, sorry. So you see that? That's how we make it a trunk port. Interface FA0/7 switch port mode trunk. And then you can see that the interface will go down and again turn up. I'll just fast forward it. And then I select some traffic and send it from here to here. It's not working. Oh, the ports are down. These ports are up. Why is FA0 slash do show VLAN brief? Oh, okay. There is no VLAN 10, I guess. That's why they are not working. So I'll just create this VLAN 10 name sales interface range FA0/1-2 switch port access VLAN 10 exit refresh it. The interfaces are up and now when I send traffic from here to here successful, from here to here first packet failed successful, and from here to here failed successful. That's what we call as routing on a stick. Do you understand that? So I will again write down the command that you need in order to create the sub interfaces. Okay. The commands are interface FA0/0, say no shutdown, interface FA0/0.10, okay, encapsulation dot 1q 10 and no I would say IP address 192.168.1.1 255.255.255.0, and you gotta follow the same for 20 and 30. So go ahead, do this particular lab and let me know when you're done. I hope you guys will be able to do this particular lab. If you are still not able to do this, we can reshoot tomorrow as well. Okay, so but go ahead, try this thing as we're up with the time. Okay, that is it for today. And we are good with the content that we had to cover today. So we are good with inter-VLAN routing. Tomorrow we will explore more things about switching. Okay, and we'll see how other things work. So thank you so much for tuning in. I hope you enjoyed the session today. I'll talk to you guys tomorrow, same time. Take care of yourself. Bye bye. Thank you.